Indices simply imply index, meaning it is when you raise a number or a variable in terms of power, you are dealing with indices. Not just writing it ordinarily like ordinary number or a whole number. But if you say 2 raised to the power 3, it means you are talking about indices. Or a raised to the power 5, you are talking about an index. When you simplify it, it's going to give you a multiplied by a multiplied by a multiplied by a. Now let us take these things one after the other. Multiplication law. In the multiplication law of indices, when you have a multiplied by a multiplied by a multiplied by a, how many a's do you have here? Simply implies a raised to the power 4. This is the index we are talking about. So in terms of multiplication, when you have 4 variables multiplying themselves, the power is 4. If you have 3 variables, a times a, it will give you a power 3. Use another letter so that it won't look as if it is only a that is the alphabet that is available. K times k means k raised to the power 2. But in this application, you may have k raised to the power 2 multiplied by k raised to the power 3. Because you are dealing with multiplication law, what do you have here? K is similar to the other k, but the only difference is that the other one is raised to the power 2, while the next one is raised to the power 3, which implies k, you are choosing 1, 2 plus 3 to give us what? K power 5. When we go on to the application, you're going to see detail of the solving of indices. The next law is the division law. In that division law, since multiplication means plus, it means division will mean minus. Division law. A raised to the power 4 divided by a raised to the power 3. The base are similar. You choose one. Remember LCM. If I say LCM of 2 and 2, it's just 2 because they are just uniform. The LCM of 3 and 3, you are choosing 3. Therefore, A and A in indices, the base are similar, but the powers are not the same. What do you do? 4 minus 3. Because division means what? Minus. Therefore, A raised to the power 4 minus 3 will give us what? A raised to the power 1. But in mathematics, there's nothing called A raised to the power 1. Instead, you say your answer is what? A. This is the introductory part of the what? Division law. Let's look at the next law, zero index law. It is known that anything raised to the power of 0 is what? 1. If you like, 100 raised to the power of 0 is going to give you 1. Now we're no longer talking about the multiplication or division law of indices. We are dealing with the zero law of indices, that is zero index. Meaning P raised to the power of 0 equals what? 1. 100 raised to the power of 0 equals what? 1. Anything at all raised to the power of 0 will give us what? 1. Let's get the next law of indices, which is the negative index law. The negative index law is talking about whenever a number or a variable is risen to minus 1 or minus 2 or minus 3. The implication or interpreting this mathematically, it simply implies that this could be written this way, 1 all over a. To interpret this imply 1 all over a squared. But in terms of number, if I say 2 raised to the power minus 2, look at the meaning. 1 all over 2 raised to the power 2. Because 2 is a number, what do you understand by 2 power 2? It simply implies 1 all over 2 raised to 2 multiplied by 2 to give us what? 1 all over 4. So that is the solution for this one. You cannot interpret 1 over a squared. It remains 1 all over a squared. The next law of indices, the one you call the power law. In power law, this power law is very important in indices, especially those of you writing JAMB. Care must be taken to handle anything that has something to do with the power law. Cube root of K or square. Let's see the next law. Then we'll go over to the application of indices. The next one is the fractional law. The fractional law is almost the same thing with the power law. It's just that in power law, you may have a square as a separate entity given to you. Then the fractional is capitalizing on letting you know when you have something of this nature, maybe minus 2 over 3 implies 1 all over y raised to the power 2 over 3. When interpreted, you're going to have y 1 all over cube root y squared. That is, when a number or a variable is raised to power of a fraction. Let's go over to the application process of indices. Example 1, 3 raised to the power 7 multiplied by 3 raised to the power 3 multiplied by 3 divided by 3 raised to the power 4. If you watch very well, this is 3, this is 3, this is base 3 too. This is base 3. It means they are the same. You are going to choose just one by saying 3 raised to the power 7. Recall that multiplication means addition. Plus 3 plus 1 all over 3 raised to the power 4. Provided you are not seeing anything on top of this 3, it simply implies 3 raised to the power 1. In mathematics, you don't write 3 raised to the power 1 or anything raised to the power 1. If you are saying P, it means P raised to the power 1. You are saying Z, Z raised to the power 1. The next, observe what is here. This is division sign, meaning subtraction. Here we have this plus this is 10 plus this 11. Since division means subtraction, it's a minus 4. What do you have? You have 3 raised to the power 7 as the solution. That is the final answer for example 1. Now let us look at example 2. Example 2. Simplify x raised to the power 6, y raised to the power 10, z raised to the power 4, divided by x power 6, y power 8, and z power 3. This time around, we'll have just alphabet alone, but different variables. We'll have x, we'll have y, we'll have z. This will give us x power 6. Look at x, we'll have x down. We'll have y here, we'll have y down. We'll have z here, we'll have z down. In this case, I'm going to apply 2 rules or 2 formulas for this. Anyone you think is easy for you, you can choose to go with that. Division means subtraction. This is x power 6, and you have x power 6 down. Division means what? Minus, I write. Then y power 10, this is y power 8, subtract by 8, this is z power 4. If this cancels, it becomes what? Minus 3. Recall that division means what? Subtraction. Now, putting everything together, x raised to the power 6 minus 6 means 0. Y raised to the power 10 minus 8 means 2. Z raised to the power 4 minus 3 means z power 1. Remember, in mathematics, you don't write power 1, and everything raised to the power 0 equals what? 1 multiplied by y squared multiplied by z, because anything raised to the power 1 remains that thing, which means our answer or solution is what? Y squared z. But if you think you don't need this, look at what you do. Or, watch it down here, x dot x dot x dot x dot x dot x dot x 1 2 3 4 5 6 dot y dot y dot y dot y dot y dot 1 2 3 4 5 6. Let me say 4 5 6 7 8 9. Y power 5 dot z power 4 x dot s dot s dot s dot s dot s 1 2 3 4 5 6. Dot means multiplication. Y dot y dot y dot y dot y 1 2 3 4 5. You are just reducing it into z3. This will cancel, this will cancel. No x is remaining again. This go this way. Here, this against this, this against this, this against this, this against this, this against this. Now what is remaining? We are left with y power 5, z power 4, all over y power 3, z power 3. To give us y dot y dot y dot y dot y 1 2 3 4 5 dot z dot z dot z all over y dot y dot y dot z dot z dot z. Y here, y here, y here, y here, y here, y here. Z here, z here, z here, z here. Z here, z here. Look up very well. How many y's are left? You have y dot z, meaning y square z. Watch back again. The same solution. Sample 3. Okay, in our example 3, just take your time to digest and understand example 2. Why you watch number 3. Number 3, this time around, we're going to involve another pattern. Square root of 125 a raised to the power 5b minus b raised to the power minus 2 all over 45 a raised to the power 3b square. Okay, can you see this? You know, most of the times, some of you, it just go direct to say square root of this. There is something you will do in a particular problem before you be able to get your final solution. What is that? You are thinking about the number that can go into this and at the same time go into this. Let's take 5. 5 here is 9. 5 here will give us 25. 5 and 12 is 2. Remember 2. 5 and 25 is 5. Okay, what next? See what you have now. 25a5b minus a raised to the power 5b raised to the power minus 2 all over 9a power 3b square. You can also deal with the alphabet. This a power 5, this b raised to the power minus 2. Make your work to be easier for you by saying 25 into this. Recall, division means what? Minus. B raised to the power minus 2. This coming up minus 2, okay? We don't have anything again at the denominator apart from the number 9. So what do you have now? You can say that 25a square b raised to the power minus 4 all over 9. Most of you make this mistake while you are dealing with the square root of powers. If you are dealing with square root of power, there is a way you handle it. It's not like the normal square root you are dealing with. Now look at what will happen to the a raised to the power 2 and b raised to the power minus 4. Okay, you ask yourself, what is the square root of 25? The answer is what? 5, okay? The square root of 9, the answer is 3. What are we left with? We are left with a square and b raised to the power minus 4. The square root of power is simply dividing the power by 2. Okay, so what is going on? Here we give us what? A1 b raised to the power minus 2. Recall, we don't have anything like A1 in mass, just A. So we'll have A, B, power minus what? 2. This can serve as your solution if you wish. But if you want to standardize more, trying to show you know what you are doing, what do? You got to write this way. 5 all over 3, A, multiplied by 1 all over B squared. You are now implying the negative index law of indices, meaning you have 5A all over what? 3B squared. This solution is the same thing as this solution. No issue. Sample 4. Okay. For part 4 of this, or number 4 of this part, you have seen how we are able to break down the one-way square root. Let's look at the next pattern. Indices with different numbers. 8 raised to the power 1 over 3, multiplied by 5 raised to the power 2 over 3, all over 10 raised to the power 2 over 3. One will be wondering, what business has 8 and 5 against 10? The truth is that there is a way you handle it. Recall that we'll have some set of prime numbers we'll make use of in indices. Is 10 a prime number? The answer is no. Is 5 a prime number? Yes. Is 8 a prime number? No. What do? Reduce 8 in such a way that when you have the power or the index, another way of writing it in index form, the number raising to a particular number will be a prime number. So what do you think is the number? Is 2. 2 raised to the power who? 3. I have reduced 8 into what? 2 raised to the power 3. Remember that 8 was raised to what? 1 over 3. Multiply by 5 raised to the power 2 over 3. Downward here, we'll have, since 10 cannot be written in index, the only solution for 10 is simply multiplication, meaning 2 times 5. And if you can remember, 2 is a prime number, 5 is also a prime number. Both of them are raised to the power what? 2 over 3. The next step here is 2 raised to the power. This can go here. We're having 1 into this. Let us separate this, meaning 2 power what? 2 over 3. Multiply by 5 raised to the power 2 over 3. You can see you have separated them, meaning we have a uniform number here, this and this, this and this. Now let's combine them together by saying that 2 raised to the power 1, I'm still writing 1 because we are still solving. If this can solve, you can solve this. Then multiply by 5 raised to the power 2 over 3 minus who? 2 over 3. If you watch very well, we have settled this part. Meaning 2 raised to the power 1 over 1. Recall from your board mass, this is 0, which is 1. Now what do we have? We're going to have 2 raised to the power, the LCM here is 2, 3. 3 divided by 1 is 2, 3. Multiplied by 1 is still 3. 3 divided by 3 is 1. Multiplied by 2, which is 2. This one is already 1, because anything raised to the power of 0 is equals to what? 1. Therefore, we will have 2 raised to the power, 3 minus 2 is what? 1 all over 3. The whole thing boils down to what? Our solution equals cube root of what? 2. Recall the law of indices that when you have y raised to the power 1 over 3 equals what? Cube root of y. It is implying here. It's as simple as ABC. This is just the application part of the indices. You are trying to apply the laws and see how the laws can be effective when you are solving. Let us take another example. Or just take your time to watch this because the base, they are not the same. You have seen how I broke down the base, change it in such a way it will remain solvable. There are some questions, the base can never be the same. and they can never come from the same family of numbers. This is 8, this is 5, and this is 10. The only one that can relate to each other is just this. And some of you go ahead to say, this cancel this. You don't do that. You don't do it in maths. Instead, you do it by separation, either by concatenating in terms of multiplication, or you raise it in form of index. Now let's see the next sample. We are simplifying. This is another one. 4 into 2 raised to the power n plus 1 minus 2 raised to the power n plus 2. This is a wonderful one. Those of you for JAMB need to take time. Again, this is sample 5 and sample 4. Study it very well. Just go through it and understand what it's talking about. So you have this, power 1 minus 2 raised to the power n. I ask the question again, is 4 a prime number? No, of course, 4 is an even number. So what do you do to make 4 a prime number? You think about just index, meaning 2 raised to the power 2. I have made 4 to behave as if it is what? A prime number. The next, this type of thing, you don't begin to say because you are seeing n plus 1, n plus 1, you like say this cancel this. If you do it, you fail. What do? You solve this type of thing by separation, meaning 2 raised to the power n multiplied by 2 raised to the power 1 minus 2 raised to the power n times 2 raised to the power 2. This is what I'm doing. I am separating it. Remember, this is together with this. Separated by what? Minus sign. The operator minus. Okay. You separate the denominator the same way. The next thing we are going to factor out, that is, we are making use of what? Factorization. You watch very well. I have 2 raised to the power 2. We still have 2 power 2, 2 power n, 2 power n. Meaning, let us factor out the ones that are similar or that are related to each other. So what do we have now? We have 2 raised to the power 2 into 2 raised to the power n. Look at it. I've chosen this. What is left here? 2 power 1. All right. Minus, I'm putting this operator, minus. Since I have 2 power n is here, I have 2 power 2 is also here, meaning nothing is remaining here. The next question you ask yourself, what do I do so that if I want to bring back these gentlemen, I can have them without any implication? It is just multiplying this by 1, meaning minus 1. I close the bracket. Divided by it, this is 2 raised to the power n into 2 raised to the power 1. Nothing is remaining here. You say minus. But before you put down a number, you have to think very well. What do you do so that by multiplication, when you multiply a particular number by 2 raised to the power n, it will land you back to what? 2 raised to the power n. It is nothing but 1 that can do that. If you say 2, it's going to be 2 multiplied by 2 raised to the power 2n. Therefore, 1 is the best option. Watch very well. This 2 raised to the power 1 minus 1, 2 power 1 minus 1. They are equal, meaning this will cancel this, okay? This 2 power n, 2 power n, they are the same. You cancel. What is remaining now? 2 raised to the power 2 to give us what? 4. Final solution. That is the end of this part 1 of indices.